Hope my screen is visible to all. Okay. Today we are going to discuss the topics like tasks, functions. So what are the difference between the Verilog tasks and system Verilog tasks and functions? OOPS concepts, inheritance, randomization, and constraints in the randomization topic. Today agenda is we are going to have object-oriented programming in the system Verilog, and these are all the concepts we are going to cover. So why are these concepts actually? What is the purpose of using them in the verification environment in the system Verilog? We have RTL. We have so many test benches to verify till up to Verilog. But now the system Verilog concepts mainly based on class-based verification. So and also it's actually constraint-driven random verification. So what's the actually why we are going to use this? So it's actually used heavy in verification environments. So as I said before, why we are coming to system Verilog means to verify the complex designs. In that particular complex, how to verify the complex designs is very important. So this actually improves code reusability and modularity. This what are the concepts I said before? They actually uses improve what are the code you written that is actually reusable to again and again to verify the new RTLs. The foundation of UVM methodology. So SV is very actually the foundation of UVM methodology. So UVM is actually a framework. So you know so many frameworks like that UVM is also a framework. That for that foundation is system Verilog and helps to build scalable test benches. So this is the thing. So this is actually a task in system Verilog. So both in Verilog and system Verilog, tasks are similar only. There is no change. So basically tasks are used, for doing something particular operation and that includes some delay. And coming to the arguments, the system Verilog actually supports input, output and in-out arguments. But coming to Verilog, it's limited and use of complex operation in test benches. So we can use some very complex operations in the task and we can call the tasks in the runtime itself like that. And coming to a basic example of a task, the task and the task name, and if you know with some delays, the task will be actually executed. So task is the arguments. Coming to Verilog, so we have only limited arguments, but coming to system Verilog arguments, we have both inputs, outputs as well as inputs. So like that. So how to call a task? In the runtime, initial begin, we will call what the task name. So this is the add values of the task name. So that we can call by passing some values. So whatever the output is there, that is assigned to the result and result will be displayed here. Coming to the functions, only inputs are allowed in the Verilog function. But coming to the system Verilog function, we have inputs, outputs as well as inputs. And functions can be void type. So functions doesn't need to return a value. So they can be void data type. And there are so many types of passing the value, like pass by value, pass by reference, pass by order. These are all there in the function, but they are not. But they are actually not present in the Verilog. System Verilog actually have that advanced things. Functions execute in zero simulation time. This you know very well, and it doesn't contain any delays. So they must return a value in Verilog, but in the system Verilog, they don't need to return a value. They can be void type and use it for calculations. So this is the basic function in Verilog and function call. How can call a function? Just by calling the function name and you can pass the value will be returned. Coming to tasks versus functions, what's the difference actually? The tasks may consume time, functions execute at zero simulation time. That's why we prefer most of the time functions in the test bench environment. So actually our verification environment executes in zero simulation time. So that's why we prefer mostly functions. Tasks can have multiple outputs, but function returns single value, if you know. And see. Now why we are coming to whoops? What is the purpose of using whoops actually in system Verilog? So you listened about whoops concepts in Java. So in Java we have class data types and the allotting of memories, new constructs and all. Similar thing is there in the system Verilog also. So basic what actually whoops contains class and object data types used in system Verilog verification. supports a modular and reusable code. We'll go further. See, that actually what the concept we here. What are the thing we are encrypting? That encryption can be takes inside a class. Class is actually allocation of memory is taken place in the runtime. But in the Verilog constructs, if you go further, if you just recap, whenever you declare any construct in Verilog, that can be allotted memory at the compilation time itself. But in the system Verilog, we mainly focus of memory allocation in runtime. That's why class actually gives that feature. The class, whenever call the function, whenever call the new construct of that class, the memory is allocated in the runtime only, not in the compilation time. That's the main function, that's the main purpose of using class data types. So they can be encrypted. There are so many functionalities of the class. So what do you call, what is an object? What is the class or what is the object? The class is just a blueprint, like just a blueprint. But object is a memory, whatever the blueprint behaves actually, the memory will be allocated. For that you get to call it as an object. What is the method or the properties? The method is nothing but whatever the functions and tasks you define inside a class that can be called as methods. And what is the property? The property is nothing but whatever the variables you declared inside a class, they can be called as properties. The class in system Verilog is actually a blueprint, just a blueprint, not actually a fully formed structure. Just a blueprint of the thing what you want to go into say. And contains properties and methods. We can write the methods. Methods are nothing but tasks and functions. Properties are nothing but variables. Everything can be written inside a class. So just let's about a module and end module. Similarly, class also looks like class and end class. Inside, whatever the thing you can return, it's your choice. Objects are instances of the class. So they are the instances of the class. Module instance is nothing but what you call while instantiating your module in another module, or else while instantiating your module inside a test bench, you will use the module instance. So the module name and the module instance and the whatever you call order based or instantiation or what you call like that. Similarly, like that, instances of the class that you call it as objects. We'll go further. We can explain the code. See. So this is the class and then class. Inside thing, whatever you want to write inside, that everything can be written here. So I'm writing int type address. So there are two variables actually, address and data. Now the function is void type. So here void, why you are using void means, functions can return any type. Some functions are basically used for returning some type, returning some value. But this function can't return anything. Just it displays. This is useful for whenever you call this display method, this display will actually happens. So there is no methodology implemented here for returning any value. So for that, should use this void. If you use this void keyword, then the function can becomes without return type, and whatever inside that will be executed. See, like this is the small class data type which contains properties and methods. Similarly, you can write the tasks also inside a class. See, so this is the class name. For this, we have to create the instance. So this is actually, see, this is the handle. Packet P. P is the handle. For just giving the P like the handle doesn't allocate the memory. We have to follow some steps to allocate the memory. So in the runtime, I'm using P equal to new. Now the memory is allocated for this class in the runtime. Up to compilation time, there was nothing. Now memory is allocated. Whenever you call through the handle, if you call this new method, then the memory is allocated for that class. Now the class is able to store the values, and we can manipulate we can manipulate what are the things inside the class. We can manipulate them and we can access them. So how to give the default values? What are the default values? Default value int is it 0. If you print the values after calling this new method, if you display the properties inside, though just you see the zeros. But what if you want to give some values, default values or whatever you want to allocate? You should call through the handle only. So handle dot address. Then you have to allocate the value through handle system. So it's simply like a pointering system. So whenever you want to access what are the things inside a class, you should call them through handle only. So this is actually a key p dot p dot, like that. You have to handle dot property, handle dot method, like that. You have to call them. You have to allocate the memory for them, and like this you have to basic class will be happens. So actually, what's the inheritance? The inheritance is nothing but, let's see. So you are, let's take your father is there, and you are now, right now you are there. So definitely some features of from your father you will get. So maybe mustache, maybe hairstyle, maybe hair, facial features, whatever the thing it may be. Like that, classes also be inherited. So what are the things like properties, methods are there in the base class? Base class is nothing but the first class you what you written. So if you want to extend them, so if you want to add some more features to the base class, you will use extend keyword. So that inheritance is nothing but what are the things, if you want to add some more features, that inheritance actually comes into the picture. So inheritance allows reuse of the existing class. Already some class is written. Now if you want to add some more features to that class, we will follow this inheritance. Child class extends parent class. So the class which is the new class which is you are going to write, that can be called as child class. The class which is already written, that is actually called as parent class. So this improves modularity, this concept. So base class, from base class, child class is extended, and so there are so many classes we can extend like that. So this is actually an inheritance, simply first class. So this is a class with name of base, so it's a property. And if you want to add some more keyword, so some more property in this base class, now we will extend, we will use this extend keyword. So new class extends this base. Now we can add int b, the end class. Like this, this child class now contains both a and b, but this parent class contain only a. So now the child is able to access the parent property, as well as it can able to allocate some default values also. This is just a declaration. Now the memory is not allocated. If you want to allocate the memory, you have to call the new construct. So now, so what is actually randomization? So if you go to Verilog, you are able to use $random. So if you want to allocate some default value like 30, 20, you can allocate directly. What if you want to make the simulator to allocate a random value? So you use $random in Verilog. But now we are going to use the randomize keyword to randomize the properties and methods, whatever the thing inside a class. So use it to generate random stimulus. So it can able to generate a random. It can allocate a random values to the properties, whatever we are declared there. So that if you want to allocate the random values, we have to use the rand keyword before the property. Then randomize is a function, inbuilt function. We have to call that one. That through code we can explain now. See, the first basic rule is inside class we have to use the rand keyword before the property whatever you declared. This is the basic thing first you have to do. Then how to call? So here I am not allocating any values. I'm just calling here. So I'm declaring the handle in the runtime. I'm allocating the memory and I'm calling p.randomize function. This is actually an inbuilt method. It makes these two values to be allocated with the random value. So address can be allocated with 20, data can be allocated with 33, like that. So by calling this method, entire properties are there, right? How many properties you declared here? How many variables you declared here? Every variable can be allocated with a default value. That can be done using .randomize, and you can display them. So if you want to call, if you want to see what's the random value is allocated for address, you have to call through the handle only, as I said before, p dot address and p dot data. That through in the console we can display these values. So now, so what is actually functionality of the constraints? So you know about randomization now. So just allocating some random values. But why it is the necessity of constraints inside randomization? Let's take if you want to generate the simulator, if you use the dot randomize, the simulator is able to generate. Let's take int keyword. Now int. So what's the range of int? First of all, it's a 2 state or 4 state or signed or unsigned, we have to know. So if you take anything which is signed, there are negative values also. But if you want to generate the positive values only, so we have to restrict them. So you have to restrict some values. So let's take I want to generate the values like 0 to 255. But the variable which you declared is able to generate from minus 255 to 255. Now I have to restrict the data 0 to 255. That restriction can be implemented using constraints. Constraints restrict random values. The random values are generated. In that random values also you have to restrict these values only should be generated. Okay, so that's why we are going to introduce the constraints topic here. We use it to create valid stimulus. So there are some invalid stimulus. Sometimes for verifying any designs, no need of generating the negative values. Only values you need the positive values. At the time we can restrict the stimulus. So written inside the class only. So whatever the thing we want to restrict the data, that constraints is there, right? That should be written inside the class only, not outside. See, this is a basic constraint. Let's say class, this is a class name. A rand keyword you are using, as I said before, is a basic. So then followed by your data type and variable name. Then if you want to restrict, it is capable of generating how many values? So it can able to generate negative values also. So 2 power 32 is the maximum value, and negative values also it can be generated. So if you want to restrict the data, constraint name, first of all you have to write a constraint. It's an inbuilt keyword. Then it's your choice. Constraint name is your choice. Then this syntax you should remember. Then inside the whatever the condition you want to write, that should be written here. So it is actually I want to restrict the data of address. That address keyword should be have here. And this is actually inside is actually inbuilt construct and we have to write inside. Then 0 to 15. Now if you randomize this class data type using like handle.randomize, then the these only what are the values inside 0 to 15 only be allocated to this address, not more than that, not less than that. So that's why here you can able to restrict the data. So this will be like I will show the output also, and going to next multiple constants also we can written. So see, there are two properties here. So for the two properties I am returning the constraints. So here I am for address I am making to generate the address should be generated between 0 to 15 and data should be generated between 10 to 50. If I randomize, address will be allocated with some random value which is of the range between 0 to 15. If I randomize data, the address like data will be generated between 10 to 50 only. Like that, this works actually. So advantages of randomization plus constraints. So we are commonly using them. Then what's the advantage? So automatic test generation happens, better functional coverage, less manual test writing. So here no need of writing the manual values, no need of writing manually. You are not allocating the values here. Just calling the randomization, just calling the randomized keyword, just calling the constraints all which are already written. Just by calling them some random values will be allocated. So much saving of memory is happening. That's why we are going to learn this one. So what's the randomizing actually flows? So first of all, you have to create the object of the class. Then we have to call the randomized keyword, and then we have to check the constraints. So whether they are valid or not, we have to check. So if we want to give, like let's take that variable is capable of storing the maximum value of 275. Let's take. But if we want to generate 280, in the constant you are writing that should be value is generated 280. That's not possible, right? Automatically slicing happens. So we have to check the constant whether it is written properly or not, and generate stimulus. So mainly, mainly we are focusing only on generating of stimulus. So the stimulus can be generated using constants. So what are the interview questions we are going to face in these topics? So difference between tasks and functions, the main thing. So how we are going to differentiate the Verilog function and a system Verilog function. What is actually inheritance topic? What is the purpose of randomization? What is the purpose of constraints? They will use this the basic things. and write class. So this is actually basic exercise for you. Or write a small class with random variables and add some constraints to limit the range and randomize objects and display the values. Just follow, just try to practice the snippets to just understand it. One second. Yeah, hope my voice is audible to all. Now we will explore what are the different constraints we have. What are the different inbuilt constructs inside the constraints we have. So system Verilog constraints. So the advanced topic actually this one. So what are the types of constraints? Soft constraints are there, inline constraints are there, distance distribution constraints are there, constraint modes and constraint inheritance is there. So what are actually constraints? Constraints restrict the values of randomized values. So whatever your values you are actually randomizing, you can restrict the values as I said before. We have to use the rand variable. Okay, we have to use the rand keyword. So ensure stimulus is valid. So the stimulus generation should be valid or not. We have to ensure before writing a constraint. So it's actually widely used in verification environment. Constraint solving concept. The system will use a constraint solver. So generally, how you have to have a thought how that tool actually randomizing what values it is able to randomize, how it is actually thinking, how it is actually allocating. You have to think right. So solver calculates the values that satisfies all the constraints. You have written few. So for a particular variable, you have written 3, 4 constraints. From that constraints, what is the actually the common values it can allocate? It will just recap that one. It will just go through that one. If constraint conflict, randomization fails. Sometimes, let's take one constraint. There is a variable called address. So you have written a constraint called constraint that should be address always should be greater than 15. And you have written another again you have written the constraint with the same address only, which is less than 15. Now the tool will get confused whether I have to generate the value greater than 15 or less than 15. At that time, the randomization fails. So if it anything common thing is there between the constraints, then it is able to generate. But if there is no common thing, it is able to fail. So call it during randomized method. So constraints can be called when you call randomization or randomized keyword. This is actually basic constraint as I said before. The constraint name, it's user defined, user applicable, and so whatever the variable you want to randomize, that variable will be written here, and inside construct we have to return. So then only 0 to 15 will be allocated to this address when you call the randomization topic, like randomized keyword. This is actually soft constraints. So what is the soft constraints? So generally they act as default constraints. They can be overridden by strong constraint. So we have written one constraint. But if we want to override that constraint with another constraint, then we have to use the soft keyword before the constraint. Useful when derived. Say derived class is modified behavior. So we will go through a snippet. See how actually the syntax look like. So this class rand and constraint name. And here you have to follow the soft keyword before the variable name. Then you can allocate any random value. So this is actually normal. So if you use soft or not, this constraint will work. So what's the functionality of the soft? We will go through in execution of snippets. So the actually basic syntax of soft keyword. So inline constructs. The constraints can be inlined also. So we can call directly the constraint in the runtime also, not only inside the class. We can have additional feature. The constraint can be written outside the class also. How it possible? We'll see. See, the class is written. Okay. So before snippet, this is actually a class. After this, I have to allocate the memory, right? I have to declare a handle, then I have to allocate the memory. See, I have declared a handle, and then I allocated the memory, and I randomized also. After that, I am using with the keyword, and address should be greater than 5. This line can be called as inline constraint. So you have to use the with keyword, and we have to say the address always should be greater than 5. Then this is actually inline constraint type. So you are writing the constraint outside the class. That's why it's actually called as inline constraint. So this is actually distribution constraint. So distribution constraint, so let's take if you want to allocate two values and with some probability, let's take address variable is there. So for the address, some random values will be generated from 0 to 2 power 32 minus 1 since it is integer data type. So I want to restrict with constraint only two values should be generated, like let's take 30 and 40. So in the 30 and 40 also, 30 should be 70% and 40 should be 80%. Like that, I want to have some probability. Like if I randomize them. So what if we want to do like that? Then we will go for distribution constraints. So this is actually distribution constraints. We have to use the random, this is and constraint name address. We have to use after the variable dist keyword. So similarly, if you go for the codes, you are using here what inside like that. Here you are using dist type. So dist 0. So I want to generate 0, 40 with a probability of 40 and 1 to 5 values the probability of 60. So we are randomized 10 times. So let's take if I randomize this class data type 10 times. Among the 10 times, 40 means like 4 times 0 will come and 60 means 6 times 1 to 5. Any value between 1 to 5 will come. That actually percentages, probabilities can be calculated using this keyword. The constraint modes, there are so many modes in the constraints also, like constraint mode, rand mode, like that. So what's the actually purpose of constraint mode? So you declare some constraint inside a class. So you want to off the constraint, you want to on the constraint, you want to use or use not use the constraint. So for that we have to say I am not like now right now I am not interested to use that constraint. Just without commenting the constraint, we can off the constraint in the runtime itself. That is actually done using constraint mode. See how it's actually we are doing. So first of all, handle dot followed by the is actually a constraint name, and then constraint mode is actually inbuilt constructor. This actually should be written exactly. And if you pass 0, then the constraint what you written before. So see, so address destroy. Okay. So the constraint will off actually. So the actually address range is the constraint name, and the constraint will be turned off if you pass the value of 0. After some time, like after 2 to 3 lines, if you write the same line and you pass the value 1, automatically the constraint will turn on again. Then you are able to generate the values between what are the ranges you want, like that. So constraint inheritance. Constraint inheritance is nothing but in the extended class also, if you are writing any extra constraint, so that values can be in the common value. So constraint 1 is able to have some range, constraint 2 is able to have some range. So whatever common values in those constraints can be allotted to the keyword, can be allotted to the variable what you have. See, this is actually Blaze class. So address constraint C1, and I'm able to randomize this address. That's why I'm using rand keyword. And the address I am restricting only it should be less than 10. But now if you see the child class and constraint C2 I'm returning here. So I'm randomizing address only, but that should be greater than 2, less than 10, greater than 2. So is there any conflict? No, right? So what's the range? It can able to generate the values between 2 to 10. So which is greater than 2 means first like it is able to generate from 3 to 2 power 32 minus 1, and less than 10 means 0 like minus 2 power 32 to 9. So what is the common range between them? This is the common range. 3 to 9 is the common range. 3 to 9 is the common range of the child class. So if we randomize this child class, only the values between 3 to 9 will be generated. That's actually the inheritance, constraint inheritance. So we have to use the different constraints names. So what's the actual real verification happens? So packet generated randomly. So actually this is a simple packet. Let's take this, the class can be called as packet. So that packet randomly generated. Constraints ensure valid protocol fields, and distribution controls test coverage. If you go through distribution, as I said before, probability is there, right? Probability concept is there in the distribution constraint. Through that, the test coverage we can control the test coverage used heavily in UVM sequences. So this actual distribution constant can be used mostly in the UVM sequences. If you further master the system will log, you can master the UVM also. At that time, it will be used. And verification. See, so here actually bit data type of 8 bits, address data. So it's the basic constraint. So here we are allocating the address which is between 0 to 15. So this is actually common interview questions we are going to ask in any interview. So just to keep a note on them. So going to have summarize. So constraints control random stimulus. So why we are actually going to constraints. So why we are actually coming to randomization, you understand. In the randomization also, if you want to control the values, you will use the constraint topic. So soft constraint provides default values. So if you want to, this can be understand the snippet. I will run them. Just wait. So inline constraint modify behavior dynamically. See, dynamically you are changing the behavior of constraint. So in the runtime, you are changing the behavior of constraint using the inline constraint topic. So dist constraints control probability. As I said before, constraint modes enable disable rules. So modes can be enable the constraint or disable the constraint. Fine. So we'll go. Yeah, my screen is visible to all. Let me increase the size. Fine. See, this is the basic constraint. So this is a class data type. Students, I provided how to run the code in the EDA also. Hope you saw the video, everyone. Hope you saw the video. And now we are going to execute the snippet. The snippet. See, this is actually class data type. So I'm using rand keyboard before the variable, and I'm using the small constraint here. The address inside should be 0 to 10. So into data type, it can able to form so many values here. But among that, only 0 to 10 should be generated. I am asking that one in any class. Now I am coming to the module, and I am declaring the handle of this packet. Packet. 1 second, students. See. So here actually what happening? So I declare the handle. In the runtime, I am allocating the memory, and I am iterating the loop 5 times. 5 times I am iterating the loop. So I am calling handle.randomize. So 5 times the randomization happening, and I am displaying the values 5 times. We'll check the output now. So you have to select I am selecting here Altec Reverb, which is actually a free simulator. So in the language, I'm just I'm selecting system Verilog. Now let's run the code. See, the values are, we are getting some values 99519. So since I am iterating 5 times, 5 values I got, but all the values are in between the range of 0 to 10. Like this, you have to understand. What if I not given this constraint? Let's check. So I am just commenting this one. Now I am just running again. See what's happening. Very big values are generating, even negative values also. You know the range of int data type. That's why we are getting negative as well as positive values also. So that's the purpose of constraint. Now we are able to restrict the data, right? So we will see the next snippet. This is actually basic understanding of snippet. We will see the constraint inheritance, constraints, types of constraints inside. We'll check this output of this code. So what actually this code says about actually. So I'm just declaring a class with a packet, and I'm using rand keyword, and I'm saying, and I'm using soft. So soft means, as I said before, it is actually giving a default value for this address. How many times you generate, how many times you randomize? Only 5 will be generated. Even though if you don't use soft also, only 5 will be generated. And see, here I am using p dot randomize with. So I am using inline constraint. So this, if you use soft keyword, automatically this soft keyword, whatever this constraint you are using here, that will be overlapped with this new constraint with the keyword. So actually we are saying here to generate the value only 5, but it is asking generate the value greater than 10. So which constraint will work? Since you use soft keyword, it will consider only this constraint, inline constraint. If you won't use soft keyword, only the common values will be generated. Sometimes constraint will fail also. So now let's see. It will generate the 5 or it generates a value greater than 10. See, it is only generating the values which are greater than 10. So it's not generating the 5 because you use soft keyword. So this can be called as hard constraint and this can be called as soft constraint. So there is no importance of that soft constraint. Now we'll check another snippet. So don't bother. I will share this codes also to you for your understanding and see. So this is actually a basic class. In class, I am using address only one variable here, and I am randomizing using inside keyword 0 to 20. Only 0 to 20 values will be generated. I am using here again. See, in runtime, I am using inline constraint address greater than 10. So here I am saying 0 to 20 and I am here saying again greater than 10. So what values will be generated? 0 to 20 or greater than 10 or the common range? The constraint will think. Now the simulator actually thinks. It start thinking. So I have to generate the value 0 to 20 and I have to generate the values greater than 10. Now it will consider the common values between them. Greater than 10. What are the values are there? 11 to 20. Here 0 to 20. 0 to 20 among the 11 to 20 are there again. So among 11 to 20 it will generate the values. So like that we are controlling the constraints actually think. The simulator thinks and it will generate the values. See, it is generating the values between 11 to 20. So 12, 19, these are all the values between 20 only, right? Less than 20 and greater than 10, simply. Like that, constants will actually. So this is actually very important as a verification in here, this class data type verification. Each and every syntax you have to remember. See, now I'm using distribution constraint. As I said before, distribution constraint actually uses the probability system. So here I have address, I am asking to generate only 0 and 1 values only. So no 2, 3, 4 or some other value. I am asking to generate only 0 and 1, and 0 also should come 70% and 1 should come 30%. So I'm actually iterating the loop 10 times. Among 10 times, 70% means how much? 7 times. So 0 will come 7 times and 1 will come 3 times. Sometimes it won't come. Maybe 2 or 3 values happens. But you have to think it as not, you have to think it as percentage. 70% of the iteration should come 0. The simulator will think like that. We'll run this code. So how many times 0 should generate? 7 or 6 or whatever it may be. Getting some error. Let's check the error. 147. So here end module is not there. We'll run this code. See, 10 times I'm iterating the loop. Among that, 1, how many times it's coming? 1, 2, 3. So 30% it's coming. 1 is coming 30%. And remaining zeros, 70% it's coming. So like that, you have to verify the distribution constraint. Now we will see the basic code. So actually this says about constraint inheritance concept. See, so I'm using one class. So in this containing constraint less than 10, and I'm using child class, extended class. It's able to asking like address should be greater than 3. So here less than 10, greater than 3. So among 4 to 9, it will generate. So if I call this child here, child handle, I am allocating child, for child I am allocating memory and I am randomizing. So what's the value should come? So greater than 3 or less than 10, or it's the like range, it should come with a range. We'll check. There are so many cases, right? So it is coming with 64875. So greater than 3 it's coming and less than 10 it's coming. So it is considering both the ranges. As I said before, child can get the properties. So it is able to access the parent properties, and it is able to override the child property parent properties also. So if we use the same constraint name here, let's take, here I am using C1. If I use the C1 here also, it actually the constraint overriding. So I'm overriding this constraint less than 10 with greater than 3. So greater than 3 means what? The big values also will come. See, the values are coming, bigger values are coming. This is actually constraint overriding topic. If you use with a different constraint name, the range will be taken. The common range will be taken. Like that, you can understand the snippets of system Verilog. So that's the thing. That's the session for today's. So I will update. I will post this EDA background link and the LMS, and that's the thing. If you have any doubts, please let me know. So today onwards, as I said before, attendance is very strict. So we are noting everyone's attendance. So absent person should come with a valid answer why you not attend the class, and that's the thing. And if you have any doubts, further doubts, we can clarify. So what about assignments? I have started working on assignments completed. I think second assignment should be completed. And now today I will provide the assignments related to both these all concepts. Just work on them and try to practice as many as snippets you can. Yeah. Thanks for joining, students. Thanks. Thank you very much.